Having seen how to arrange digits to form a number, today we will look at how to arrange people in different positions. So let's say I have 7 people and there are 4 chairs lined up in a row. The question is, in how many different ways can the chairs be occupied? Maths does not make a distinction whether you are picking digits and arranging them in position or whether you are picking people and arranging them. So the logic goes same. The first chair could be filled in 7 different ways. Having filled in, the same person cannot come in, so there's no need to mention repetitions or no repetitions. The second chair could be filled in 6 different ways. Third one in 5 different ways. And last one in 4 different ways. Since I have 2, all the 4 chairs need to be occupied. It is going to be a product, and so our answer is 20, 120, that is going to be 840. Exactly similar to our first question on forming numbers. If the number of people were equal to the number of chairs, so there are 4 chairs, 4 people. The first one could be filled in 4 ways, 3 ways, 2 ways. There's only 1 left, so 1 way, and the answer is going to be 4 factorial here. So to generalize, if the number of positions and the number of objects, distinct objects that I have is same, let's say n, they could be occupied in n factorial ways. So if there's no difference, why do we treat it differently? In numbers, while forming numbers, you have conditions like the number could be even, odd, divisible by 4. When you are arranging people, the conditions is a little more different. Let's see it with an example. I have a boat. Let me try drawing a boat. And this boat has to be manned by 8 people, but 4 are going to sit on the left and 4 are going to sit on the right. I also have 8 people with me to man this boat. However, out of these 8 people, 3 of them insist that they are going to sit on the left side only because they are more comfortable rowing that side, and 2 more people insist that they will sit on the right side. The question is, with these conditions, in how many different ways can I man this boat? Let's satisfy the conditions first as usual. So on the left hand side, if I look at, there are 3 people and there are 4 positions. One of the person from here could sit in or could choose his position in 4 different ways. The second one, 3 chairs would be left, so he could go and place himself in any of the 3 different ways. And the third one in 2 different ways. So we would have 4 3s are 12, 2s are 24 possibilities of these 3 sitting on the left side. Having they being seated, let's look at the right hand side. There are 2 people, 4 positions. First among them could sit in 4 different ways. The second among them could sit in 3 different ways. So 4 3s are 12 ways. What do I do with them? Think, these are 24 ways. For each of these arrangements, there could be different ways in which the other 2 on the right are sitting. So the answer is going to be a tree-like structure product. Or in other words, I have to make the left hand also be filled in and the right hand filled in. Is that all? Not really. I have remaining. So how many are there? There are remaining. Let's see how many people are there. Remaining. Give me a minute. Remaining. There are going to be, out of 8, 3 have gone here, 2 have gone here, 5 have gone. Remaining 3 people are there, and there are 3 positions, and they could be filled in 3 into 2 into 1. Again, for each of the previous ways of sitting, these 3 could interchange positions among themselves and result into different solutions. So we would again have a product. So the answer in our case is 4 into 3 into 2, 4 into 3, and 3 into 2 into 1. That is 3 factorial, complete. Another example. This time, instead of people, we will be arranging, let's say, cars. So there is a parking slot or a parking lot with 8 different slots, 1, 2, 3, 4, 5, 6, 7 and 8. So there are 8 marked slots in a parking lot. I have 8 cars, so it is going to be arrange these 8 cars in this parking lot, but there's a condition. What is the condition? There are exactly 4 cars between, let's say, 2 specified cars. So 2 cars are specified and there needs to be 4. In how many different ways can the cars be parked here? There's a condition about these 2 specific cars, so let's satisfy those conditions first. If one of them is parked in the first slot, then there necessarily has to be a gap of 4 cars before the other one is parked. So 1, 2, 3, 4. The second of those 2 specified cars can come in this place. Right? And there are 4 between them. Is this the only way for these 2 specified cars? No, they could even move 1 step towards the right or 1 more step. So let's say the 2 cars could either come in the 2 squares, or they could come in the 2 circles, or they could come in the 2 triangles. So for these 2 specified cars, I would be having 3 different ways or 3 selection of the parking slots. Right? Let's say I select any one. So let's say we'll say the 2 cars are parked in the circles. Now, is that all, or can I still do some more arrangement for these 2 ones itself? Now we have just selected the 2 slots, but which of the 2 car goes where? Could I see this as a sub question? Two objects, 2 positions, so they could be arranged in how many ways? 2 factorial ways. Here it's simply 2. So we have arranged the 2 specified cars. Having satisfied the question, we just take a pause, we reassess our situation. I have 6 slots and 6 cars to be parked, and they could be parked in 6 factorial ways. Needless to say, all 8 have to be parked, so it is going to be a product. And so our answer here is going to be 6 into 6 factorial. Over to the next example.